So we're going to have a really quick introduction, and we're going to get right into the meat of the program. It's great to see so many of you here tonight. So we have a parent organization, PASS, Professional Association for SQL Server. I'll tell you a little bit about what PASS does as part of this introduction. Membership is free. You can access a lot of different technical resources at SQLPass.org. We've got sponsors for the organization. SolarWinds, Pyramid Analytics, Microsoft, and DesignMind are our current sponsors. And upcoming meetings, so we never meet in December. We take the month off. And then we'll be on a regular schedule January and February here. And then in March, we're going to have a SQL Saturday, which I'll talk about in a moment. For people who attend meetings in San Francisco, Microsoft is moving their office probably 6 or 8 blocks from where they currently are. And they're not going to have a meeting room available for us until our first meeting there will be in April. So we'll have our meetings here, but not in San Francisco until April. Upcoming, how many of you have attended a SQL Saturday here in the past? So almost like a third or so. It's a one-day free event. We have 6 different tracks, different learning tracks, depending on what your focus is, what your professional focus is. And we had 31 speakers last year. We had 640 people attend. We rent out this entire facility for the day. And food, there's an after party, so it's really a good event. And
our awesome event, you get to see speakers that typically will cost you thousands of dollars to be able to hear. So speakers from around the world will be coming here, and it's really, and hey, it's free. It's only going to cost you your Saturday, so sign up and guarantee your place.
And it's a volunteer-led event. We handle most of the work for this kind of behind the scenes and don't look for a large group of volunteers until the day of the event. So I've got a sheet that I'm going to pass around. If you're interested in volunteering to help us out at the event, just give us your contact information. I'll send that sheet around during the meeting here. And the event here, last year's was the largest SQL Saturday anywhere, and the quality of the speakers, the quality of the program was really outstanding. We got a lot of attention in the SQL Server and Microsoft BI community for it. This event will be, I'm sure, every bit as good. So March 28th, save that on your calendar, and hopefully we'll see you here. PASS offers a number of things besides SQL Saturdays. They've got 24 hours of PASS, which is 24 back-to-back webinars put on by experts in our field. SQL Saturdays, as I mentioned, the PASS Summit was just held the week before last at 5,800 attendees this year. It's in Seattle. It's the largest SQL Server and Microsoft BI conference in the world.
Business analytics coming, right?
Yep, in April.
20% cloud.
Yep. So the PASS Business Analytics Conference is probably not probably not right for a lot of the people in the room here. You're probably not working as an analyst, but you're providing data to the analysts. And so as information about this comes out, I hope you'll think about forwarding it to the people who are doing analysis, like the Excel people and the analytics people within your organizations. We'd like to try to give people a chance to make announcements. If you're looking for work, if you're trying to hire somebody, I failed to mention a meeting that would be of interest to this group. I'll make an announcement. my company, Design Mind, we're looking for people in several positions. We're looking for a senior .NET developer, a senior Microsoft BI consultant, and several Hadoop and data science positions. So if that's you, or if you know somebody like that, feel free to reach out to me, and we'll talk about it. Are there any other announcements? Yes.
Yeah, my name is Matt True, database administrator, looking for Oracle with MSQL, HB.
Okay, great. Thanks, man. Yes,
Yeah.
If there are any C# developers here that are interested in getting a C# group going in the Valley, please see me after the meeting.
That's Fletcher Johnson. If you need to track him down. Any further announcements? Yes.
My name is Robert Stoke. I'm a business analyst, and I'm looking for work. I have experience with Microsoft SQL and Oracle SQL.
Okay, great. So, if you're interested, if you want to talk to him, you can catch him right after the meeting. You'll stick around for a few minutes, right? Okay, great. Any others? Okay.
So, yes, with that, we'll introduce our speaker for tonight, Mr. Val Hoover from Espresso Logic. You can read all the details on the slide in front of you, so I don't need to read it for you. So I'll just ask Val to come Thank you.
He's going to introduce me as one of the people you don't have to pay $1,000 to go see. What do I do? That looks familiar, you're in the right place. So maybe 10 years ago, I was working in a company, Versada, and one of our customers called me up and said, "You got to take a look at REST." He's a very smart guy. I went to the wiki, looked at REST, representative state transfer. I kept reading, and when I got to the part about idempotent, I figured I was in the wrong place. You know, why are they talking about Egyptian pharaohs when I want to be reading about database stuff? So I'm going to give you the presentation I wish I had been able to find when I first heard of REST. It's going to save me a lot of time, maybe it'll save you some time. The REST that I'm interested in particular, is based on SQL databases, so I'm going to draw some lines between a REST and SQL database. And then we're going to talk about if REST is a good thing, and that's what I believe it is, but obviously you'll make your own call. If you think REST is a good thing, then how do you build it? It's not a trivial thing to build, so we'll talk about that, including how to build a multi-database REST service. And we'll take a brief look at some of the things that should go inside the server, in addition to just having it exist. Okay? Okay? So I'm going to introduce the word for the day, which is also the proof of why the marketing people get very nervous when I read the premises. Detricidination. Says it all, doesn't it? So what I'm trying to communicate here is you've got data. That's the first piece. And you want that data to be as available as electricity. It's a connected world. There's mobile apps out there. There's integrated computers out there. And you need to make that connectivity happen very quickly, and it needs to be safe and secure and high performance. So that's the data is connectable as electricity. But if you look at how to build these RESTful servers, they're a pretty big project. So you'd like some automation to take off your shoulders the recurrent pattern, the boilerplate munch that it takes to build these things, because otherwise you're looking at a big job. So that's kind of that part. So let's talk about why would you want it? What is REST and why would you want it? Here's a cute little cartoon that talks about so the young lady on the left okay, is this better? Can you hear me?
You need to put it.
Is that better?
Keep going.
Still better?
Yeah.
Okay. So the young lady, she's our stand-in for web apps, mobile apps, and other computers that need to talk to our data. And, you know, can you hear me now? They can't. This fellow was wearing his database hat. And if you think that ODBC or JDBC is going to solve this problem, they can't. There's a network, you can't make a separate team call across the network. That's what REST is supposed to solve. And it does so not just by making it networked, but even better, and this is the big deal. It makes it network available to sort of basically any kind of architecture you've got. So if you're an Apple person, or a .NET person, or a Java person, or a Ruby person, you can all speak REST. Max likes to tell the story that in Google, you know, they're doing okay, they're growing fast, and everybody gets to pick their own language. So how do they share each other's work? The answer is go for whatever you want to do, but whatever you do, put a REST service on it. That way we can use each other's stuff. So there's even a REST API in Google for documents. Things that don't feel like databases in any way. So REST is that networked, service-oriented architecture that provides, in this case, accessibility to your database. So what does it look like? We're not going to spend too much time on this. But so REST sits on top of HTTP. That's the stuff you get to the internet with. So every language, every architecture can issue HTTP calls, obviously. And there's these tools like curl. That's what this is showing. And you can just curl Google and you'll get back on a suite of stuff. A REST call is this one shown here. There's a couple pieces of it. I wish I could. Where's this one? There it is. The point's on there. Okay. So think of this as like the location of your server. So that's like whatever. This is the good stuff. This says, within my server, what do I want to talk to? So I'm trying to talk to product. People call this an endpoint, some people call it a resource. I think those are basically the same name. So, and the next thing is, what am I doing to my endpoint? And what this is saying is I'm trying to post to it. We'll get that in a minute. I have no idea what this is. I hope I'm not killing people. And the third piece is the payload. That's typically these days in JSON. JSON is basically a JavaScript data structure. Also XML is used. But that's the way you send data. Like if you're trying to insert something, this is basically inserting two parts. Part number A and part number B, for whatever amount of money, to our RESTful server. A couple observations here is that this is a very database, if you're a database person than I am, this should feel pretty comfortable to you because it's a very object-oriented protocol. I'm not but it's got objects, it's got operations, as opposed to SOAP. SOAP is basically, you issue a subroutine call, you get some data back, what you think of as customer maybe 8 or 10 or 20 different calls, and they're only connected in your mind or in your documentation. Whereas REST says, we have resources called product or customer or account or whatever, and they all have these operations put posted to it. So it's a very sort of noun and verb kind of architecture. And JSON, that's that curly-Q syntax, is the way that data flows back and forth. Turns out that if you're trying to talk to a mobile phone, often those are written in JavaScript. JSON is JavaScript. That is a valid JavaScript data structure. So you basically just read it down, and there's nothing to deserialize and that kind of stuff. It just is there. Every language has very simple capabilities to translate JSON into POCOs or POJOs or whatever you call WO in your language of choice. Questions here? So how many people here have built the REST server? So I see maybe half dozen people. Okay. How many people will soon have to build a REST server, say in the next 6 months or so? Another half dozen people. Okay. Right. Did you have fun building a REST server? That's a big job. It's a big job. Okay, so if I'm a database person, how do I come at REST? We sort of already covered this. What I used to think of as, sort of my stuff. It's my model. So, I've got in a database world, I'd say my schema. So my customers' orders, items, parts, employees, all my stuff in my schema. In REST, that's kind of the server prefix of that big long URL per se. That corresponds pretty well. The objects in my database, views and base tables, they are these resources, our customer, order, employee, part, what have you. We rename the operations to match up. These are HTTP names. So, get, put, post, and delete correspond to those SQL verbs. SQL doesn't exactly have the concept of a payload, but I wanted to just put that on the chart. This is pretty much what you need to know about REST. This is the basics of what REST is in terms of how to translate from database. As we're going through, I'd like to keep this as informal as it can be. If you have a question or a comment, just type up, please. Just raise your hand or shut up. So that's pass one of REST. That's not going to get you very far. What it will get you is kind of heaps of scorn and abuse from your mobile programmer friends, because they'll roll their eyes and they'll huff and puff, and they'll say, that's not the kind of API I want. That's just flat relational stuff. You're stuck in the past. And then the conversation will rapidly go downhill after that as people insult each other and so forth. So what are they after? What they're really after is the notion of network performance. Remember, this is not some code inside a computer that's making calls to the JDBC or ODBC. This is across the internet to like a mobile phone. So it really matters how much you're sending across the wire in a most general way. And the first thing you have to do is limit the number of trips. If I have to make multiple calls to assemble the data to put on my screen, I'm going to get that latency that's implicit in the internet multiple times. So what's the example? If I want to see a customer and some orders and some payments on my mobile phone or my tablet, I don't want to be making 3 calls for that. That's going to hurt a lot. So built into the whole idea of REST adjacent is what, and there are different words for this, but the notion of non-flat results, nested docket results, things with indented, customer with indented orders, orders with indented items. So you can get collections of different kinds of data in one call, as opposed to making several calls. Very basic idea. The other stuff is stuff you're already familiar with. If you're on a mobile phone, you want to make the rows as small as they should be. If the database row is gigantic, you want to just get the column you're supposed to have, because if you send less data, it will go faster. Both in terms of the width of the row and the number of rows. And the classic way you make a computer look stupid is you say, show me all the customers in New York, and down they come, and that's absurd. So almost certainly, every one of us here has had to deal with, whether it's a web app or a mobile app or whatever, you pretty much have to deal with this notion of pagination, giving out data, a bunch at a time, maybe 20 rows at a time. It turns out that becomes a particularly tricky problem when you're doing these nested documents. We'll take a look at that. Pretty obvious so far? So the point here is that on the prior slide we said there's some pretty obvious mappings from the world of SQL to the world of REST, but don't take it too far, because if you do, you'll get shot up. A simple SQL pass-through is not going to be good enough for your REST server. Okay, so this is what REST looks like. Up at the top, so the way you speak to REST is you give it a URL. Remember, that's the server and my resource at the end. And I'm doing a little more here. So with my server, I'm saying something about customers. Now, We haven't talked about this yet, but if you're a database person, you're used to the notion of views versus base tables. That's essentially what that resource is. You don't know whether that resource is necessarily something that's physically stored or kind of virtual thing. It could represent a definition of what column to project. It's kind of implicit. Notice after it, that question mark business, that's standard HTTP. That's where you specify arguments. Those are things that you'd expect. Filters, what to sort by, maybe what my page size is. You know, lots of stuff, but filter and order by are the most important. And the stuff from 1 to 19, this is the JSON payload that came back when I issued that get. So there's some important stuff in there. The first thing is on line 3, we're seeing set up, and there's multiple ways of doing this, but this is one, that says, I know I'm going to get a lot of rows out of this, we all want to get lots of customers, so we're going to paginate it. And one particular implementation says, here's the first 20 rows, and to get the next 20, just pluck that URL out there and run that, and you'll get the next 20 rows. As a programmer, the point is, you don't have to peek inside what that URL is. You just take it, and when you're ready for the next 20, when the user scrolls on the screen, you just submit that URL, like at that top line, and you get the next 20 rows. And the system has had to remember what filter you did, what order by you did, pick up, you know, from 21 to 40. Okay? So that's the pagination. And I mentioned that pagination gets really tricky. Let's jump ahead. If you look at line 13, this is the nested document comment I was making, where you want to send one command and get multiple kinds of data back. So we're showing here we're getting a customer, it's alpha with their balance and so forth. And that customer's orders. So this is the multi-document stuff. Now take the notion of pagination and say, well, you know, I could have lots of customers, that's good. Each customer could have lots of orders. So now I need to be able to paginate all of these multiple streams all the way down this nested document gang. And, you know, that's a lot of stuff to program. That's just, you know, a lot of work. Last thing I'll point out of this is at the bottom, this notion of optimistic locking. Probably everybody knows about that, where you retrieve data, you alter it, and you put it back, but in the process of putting it back, you make sure that it hasn't changed since it was retrieved. That's something you'd have to build into a REST API. That doesn't come out of the box. So a way to do it is, for example, have the system, have your REST server put a checksum on each row, so if that row was subsequently updated, we can tell if it got changed or undone. So these are the sorts of things that are, you know, a professional for enterprise class API, you're going to have to sort of provide for all that stuff. Okay? This is a good time for questions. So we're kind of done talking about what on earth is REST and why do you want it. So hopefully I've made my case. You want REST as a networked data access protocol. And it's a service-oriented approach to it so you can get it from any language. That's a big deal. Almost all of us work in shops where there's multiple language, mobile apps, and so forth. So REST is a really, really big deal. Any comments or questions on REST? Because we're moving on from REST. Okay. So how do you create a RESTful server? Well, people here have done it. I happen to be a Java guy. So you go get your favorite framework or a set of frameworks. Jersey and Jackson, and basically it's a gigantic exercise in fairly complicated configuration, and then quite a lot of coding where you say, you're basically building a web server, so you have to say, when this kind of URL call comes in, call this code, and this kind of comes call this code, configure, generate the lines of XML files, which we all love to try to debug, and then basically that gets you down to, your code goes here. And all the stuff we just looked at, pagination, optimistic locking, nested documents, all the SQL handling, the conversion of the SQL results into JSON. You own it. There's method calls to build it, but everything you build is going to be a lot of work. It's going to be a lot of work. So even for a simple RESTful server, you know, my friends in the SI business talk about if they have to, you know, win a job to show a customer, and they have to build a prototype, maybe a 20 screen app or a 10 screen app, something not particularly big, you know, to build a prototype, they typically allocate, this is just for a prototype, 2 or 3 weeks for the server and 2 or 3 weeks for the client. That's for a trivially small, not dealing with property pagination and so forth, just to show the client that they understand what the business is about. So these are pretty big projects, and they can become very big. So now we get to this sort of, funny idea about, can we make that a little simpler? What would it be, instead of writing, weeks and weeks, more like months and months, of pretty complicated stuff, what if we could create a server just by saying, my database is there, figure it out. And then, that'll give you default endpoints for every table, the base table, and view table in my database. That'll be up. Just, because I said, there's my database on its system div. Secondly, what if I could create these nested resources? You can think of these as views. What if I could create these as simply as I click, and sort of pick things off lists, with the additional services for our mobile friends to add nested documents and multiple databases. So the idea of building a default API is by connecting, finishing out the API by doing point and click, and then somehow figuring out the logic and security. That's what I'm talking about, trying to automate the connectivity of your database or databases. It's time. Are you gonna play? Sure. Well, good. So this is Max. Max is the ace programmer of our team. He's the one who makes it all happen.
Hello.
Hello. Hello.
Hello, everyone. My name is indeed Max. I can confirm that. Now drag me out of my cave today as punishment, I think, for my sins. So I'll try to talk a little bit about this. So what we're showing here is the notion of building a REST service, not just out of a single database, but out of, in fact, multiple databases.
Are you doing this one?
Yeah, I guess. I don't know what I'm doing. So maybe the simplest thing to do is basically just sort of show you, how this works. So I am going to switch to a different environment. This is perhaps a little small. Is that any more readable? Good enough?
No, it needs to be a little bigger.
A little bigger?
That's good.
Or big enough? So the notion here is that all of the relational databases have a fair amount of information built into them. In other words, schema and other meta objects. So we should really be able to build a basic REST API just from a relational database. So what I can show you here is the actual connection going on. And here I'm just going to use my Northwind database simply because it's the easiest way to go. But I could, in fact, connect to any database that I have access to. So here I'm connecting to my database. We're scanning the schema, and we're done. At this point, I now have a REST API. So the REST API that I have at this point is a very basic REST API. We basically scanned the tables, the views, the stored procedures, and created endpoints for each one of them. So that's a good starting point, because at this point you have, a REST API that would have taken you a non-trivial amount of time to put together. But as Val said, that REST API is only of limited use because it's a one-to-one mapping. If I wanted to have a complex object, I would have to, like Val said, make multiple calls, and that's exactly what we want. So we want to create what we call resources. If I can find the cursor, there it is. And resources are a way of joining things together. So let's assume that I want to create a resource for my customers, and I'll call it gusts. And I might decide, I don't necessarily want all my attributes. Maybe I just want certain attributes so that I don't transmit more data than I have to over the wire. Once again, optimization.
The other thing to point out here is you can alias these, so that if your database has goofy names, you can build an API that has names you wish you'd used initially.
Right. But not that your database has, goofy names, of course. So I wouldn't accuse you of that. But that is a capability. So in the attributes here, once again, I might decide, well, I'm only interested in the amount total, and we don't call it the attribute total for this particular environment. The ship date and whatever the required date. And I now have myself a very simple tree. Now this is a two-level tree, so it's about as simple as you can get. Let's see if we can exercise this resource here. This is a resource that I have here. Here it is. I'm going to exercise it. And I now have data coming out of my database, but this is joined across the tables. So that's kind of cool. That's fine. You may or may not be able to see the actual aliasing of the attributes. So I think
There's the nested document stuff. On line 12 there. This is the customer and their orders.
so. That's all kind of cool. And at this point, we've already sort of gone beyond basic REST. Basically, a number of frameworks and products will be used at a basic level of REST. Sort of turn a table into a REST endpoint. We've already gone beyond that. As we start diving deeper into this, we're pretty soon going to realize that a lot of projects need to have more than one database. In other words, I need to bring in and join data across multiple databases. Perhaps my customers are at Oracle, and my sales data is in SQL Server, and perhaps I also have some MongoDB out there. And really what I want is I want to sort of join all of this together so that the application can just make one call. The server then retrieves the data as required, puts it all together, and it's one response. We get good performance. And the application doesn't have to make multiple calls, which is the bane of developers. And this is here what we're talking about, as in I can connect to another database from this list here. But not shown here is the support for MongoDB, which is supported at the resource level.
So is this read-only, or do you guys also be able to post?
So this is most definitely not read-only. Everything that you do here, assuming of course that the permissions are set up properly, is in fact fully postable, puttable, and readable. So as you bring in data from various tables and views and even potentially stored procedures, obviously the stored procedure is not two ways, but for tables and views, assuming that the views are updatable, that can all work together. So perhaps the best way to demonstrate this would be just
I switched when you were not looking.
okay.
So we switched to a different project, a different API, where we've already got two databases, just to illustrate what Max was talking about.
So in this case, we have a resource here that is defined basically by joining two databases across it. Each database has a unique prefix. So here I'm using customers from my sample database and the purchase orders from my demo database. And of course I can exercise this and I will get what I would expect, which is this guy. And there it is. So as you can see, JSON, which is the typical language for representing data in a REST service, is fairly easy to read. Not everyone uses JSON. Some people use XML. I think XML is sort of a little bit on the way out here, but it's still quite present. Now, what was I going with this?
I think it's my turn.
Is it your turn?
So what did we do? What we just saw was instead of writing all the framework stuff, and there's jillions of frameworks, and they're all very complicated, you can create a REST API just by connecting. There's other products that do that. You saw a point-and-click UI, I should have said, to create these multi-document or nested document APIs that connect multiple databases. And your question was almost a perfect plan. What about logic and security? For example, somebody wants to update this stuff. So, I guess I can do this.
There you go.
Can you make it go into a presentation mode again?
Certainly.
So, where the computer, topology these days is pretty complicated. Where are we going to put our logic, right? We got choices. We could put them on the far left. There's our clients, from our mobile phones to our web apps or other systems. That's what the lower box is. That's one place we could put our logic. Another place we could put our logic is this RESTful server that we're trying to build. And a third place to put our logic is in the database itself, triggers and stored procedures. So we've all dealt with this question for at least the last 25 years. And it's not a new question, but it still is absolutely in front of us. So what's the right answer? Well, let's start, I would suggest, with the wrong answer. The place you don't want to put your logic, almost under any circumstances, is under your client buttons, right? Which is sadly often the usual answer, but that's another discussion. Why is that such a bad idea? Because it's not shared. If you want to make that same logic available through, to another computer system as opposed to UI, that doesn't work. A different web app or a different mobile app, that logic won't be available to it. In addition, if you do something like buy 5 more yo-yos, the business logic to recompute to reorder the parts, if you need to update the order total and the customer's balance, is going to require all those accesses to go get data to do that business logic. And that's exactly what we wanted to avoid with these multi-document APIs. We want to avoid multiple trips to the server. We don't want to do an update either, so that's a bad idea. So that's carefully coded in red, very symbolic. This is like, don't do that. You can make a pretty good case that putting the logic in the database is a reasonable thing to do, because it's shared. No matter how you get into the data, the triggers and storage procedures are going to work. That's the good news. The bad news is the database in and of itself, whether accessible by JDBC or ODBC, it's not network available. You're still going to have to write the RESTful server. So that would be my choice. If I put the logic in the RESTful server, if it were easy to do, that's a big if. If it were easy to do, that would be an API that not only supported network access that was efficient, but could enforce the logic and security of my data. If it's easy to do. If it's not easy to do, maybe I'll go after the triggers and stored procedures. And we're talking about a lot of work here, right? I'm sure everyone can quibble these numbers, but I'm just looking for order of magnitude. My guess is that if it's triggers you like, if it's C# you like, if it's Java you like, whatever, that you're going to write a couple hundred lines at least of code per table. Right? I think that's a fairly conservative number. Let's say you're a program that is 4 times faster than national average, and you can do 50 lines of code per day. That puts you 4 times faster than national average. You should get a raise, but that's a different discussion. So a dinky little database of just 20 tables is a whole year's worth of work. That's a lot of work. Right? A fairly, representative database of 100 tables, well, that's a couple years of work. And a reasonably interesting sized database of 500 tables, that's a lot of work. And that's a fleet of people for a year, right? So this is a lot of work. It would be nice to have a way of squirting through that without having to work so hard. And here's what I'd like to show you. How many people here have heard the term reactive programming? Is that okay? And what do you think of it in conjunction with?
Programming, seeing things immediately on this, or
Yeah. But in what use case? Have you seen like client frameworks that are reactive programming, that kind of thing?
like the front end and the back end,
Okay. Who else have you ever used reactive programming anybody here? It's pretty new technology, pretty new thing.
Or it's asynchronous kind of
Right, message-based. Right. It's really an outgrowth of the kind of an observer pattern. And what the observer pattern doesn't do is it doesn't order the people listening for something if they have dependencies between them. So reactive programming says, I know how to fix that, and then they fix that, and they make provisions to have run all those listeners on different cores, this is very deep high-tech stuff. I mean, Scala, and blah, blah, blah. Big deal. On the other end of the spectrum, you've all used reactive technology probably multiple times a week in the form of a spreadsheet. That's really what a spreadsheet is. It's, I make a cell formula that references A, B, and C, and if I change A and B or C, the original referencing cell reacts to that. That's a really very powerful programming model. In fact, that's a remarkably powerful programming model. Right? So what we're showing here is applying that's not the technology, but the mindset of a spreadsheet for business logic. So what we're doing, and we'll show you the demo here, is that we're assigning, in fact, why don't we just do that? Because we also have a fun little joke. Not that fun. The SQL Server meetup. So what we're showing here is we're showing, and this is obviously just sort of fiddling around. We're showing for some objective, some topic. We're showing the rules that actually make it happen. And we're showing two rules here that are pretty interesting. And they show you what these reactive programming rules are. What is a spreadsheet? Basically, you take a cell and it's either data or you assign a spreadsheet cell formula to it. Well, in the case of a database, there's no cells, but there are database columns. So the notion of applying this technology says, assign a database expression to a column. And what the system will do is look at everything that's referenced in it. And if those things change, it will recompute the referencing column. And it will change like a spreadsheet. So that's what that first thing is, where the balance is the sum of the purchase orders, the unpaid purchase orders, basically. Okay? Now, that's the kind of statement you might make to your business users. This fields the sum of blah, 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 blah. Right? As developers, think about imagine you're going to write a trigger. Right? What are you going to do in a trigger? Well, you have to worry about deleting a purchase order, inserting a purchase order, changing a purchase order with some of the changes. If you change this foreign key, then I got to adjust two different customers. If I change the paid flag, I got a whole bunch of work to do. If that's, if that's what I write down in my cocktail napkin spec, that's a lot of work. That's a lot of work, right? With reactive programming, that is the work. You just make that expression. And reactive programming means the system's job is to parse that, figure out the dependencies, and react to them if they're changed. So that's the first piece, these multi-table computations. The second piece is a validation that says, don't commit any transaction if this expression doesn't turn out to be true, namely the balance of value less than the credit limit. You can see how these things feed into each other because the balance itself is computed. So we're going to look at the resultant computed balance, make sure it's within the credit limit. And this is all going to kind of just work without me doing anything, just by laying these rules in.
Now, can you do that just on one database, or since you have different sources?
Multiple databases. We don't have two-phase commit, so you're going to have to deal with the exceptions, but it will work across databases.
Is this chain? Is it based on chain kind of rules, or is it?
Yeah, well, these rules chain implicitly, right? Basically, if you reference something that itself is derived, then the system has to notice that and take the corrective action.
Or if you needed to do something in like a transformation or something like that, a sequence of calls. So you have to do this first, do this, and then do this.
Yeah, and I would love to have that discussion with you. We ran out of time here. There are things that are procedural, but they're pretty rare. Most of the time, you can do it with just saying, here's the end result, figure it out. However, what you're saying is true. Max, why don't you go look at all the rules and we look at the JavaScript one. So in addition to the, let's call this declarative, reactive programming logic, you can also do these things that we call events. You would want to call them events too. And what this is showing, so does anybody recognize what language this is?
JavaScript.
JavaScript is right. So this is server-side JavaScript. This is not running on your mobile phone. That would be kind of silly. What it's doing is it's an event for purchase order. And it says whenever a purchase order is changed, run this JavaScript event handler. And this JavaScript event handler is passed the row. You can see the row there on the first line, row dot amount total. Right? So these objects, these row objects, are built. They got built automatically from the interrogation schema. Right there. Think of them as active records if you're a Ruby person. Think of them as hibernate end records or what is the Microsoft Entity Framework? These are all kind of the same thing. These got built automatically. And I just do my JavaScript work. I can do REST calls, do SQL calls, do updates, kind of whatever I need, in whatever order I need to do it. So this is like your escape valve. Whatever you need to do, you can do this way.
Maybe a stored procedure.
Call a stored procedure, call a REST service, knock yourself out. Or not. Okay?
If I can just add a little bit, the beauty of the declarative aspect of this is that it's actually a relatively intuitive thing if you think about it as it's the same technology that powers a spreadsheet. We've all had the experience of building a spreadsheet, and if you spent more than a couple of hours on a spreadsheet, and you step back a little bit, and you realize, okay, I have my spreadsheet now for computing my mortgage or my taxes or whatever. How long would it have taken me to build this in a language of your choice? If I had to reproduce the same functionality I really don't care what it is, almost any language, you very quickly realize this would have been a staggering amount of work. It would have been very, very difficult. So spreadsheets do their job very, very well. They're kind of a specialized system, but what they do remarkably well and work remarkably fast. And then also the whole chaining is also kind of naturally. How does a spreadsheet work? Well, it basically looks at how you define your spreadsheet, what formulas and sums and whatnot are defined, and it does the dependency analysis. It basically builds a tree that figures out everything that's dependent on everything else. And then when anything changes in the spreadsheet, it's going to look at that dependency analysis and it's going to figure out, well, the user has updated this cell. Does anyone depend on this cell? Yes, in fact, there's a bunch of other cells that need to be refreshed. Let's refresh them. Now, does anyone else depend on these cells? And so on and so forth. That's the thing. It's the exact same idea here.
The metaphor is almost a perfect one. The additional difficulty of doing it for databases is obviously that SQL's better, right? You got to do this stuff and do it as efficiently as you would have done it if you built it by hand. Otherwise, it really doesn't count. You've got to be able to minimize the number of SQLs going on in almost all cases.
So, who is the target audience for this product? Is it a developer or a business user?
Well, I'm glad you thought it would be a business person, but it's not. It's developers. But I would make the comment that a business person could read this, because it looks kind of like a spec. Right? The fact that it's executable is quite a bonus. I would not expect a business person to be able to build these rules. You have to understand relationships in database design, performance implications. I mean, there's a lot of stuff that we just know. However, to ask a business person to read this is perfectly reasonable. Oh, wait a minute, you're missing the tax calculation. What are you doing? Right? So I think of it as a forehand piano bench, right? Where you're doing most of the work, but the business user can keep up with you and understand, is this what I wanted? Is this making good sense? So I think it enables collaboration in a way. I mean, you're not going to show a business user your code. They'll fall down that.
And then the other big win is that in a typical middle end, when you express your business logic, very often it's going to be just a massive amount of code, which you're never going to be able to show to a business user. Using declarative expressions, these reactive expressions, each expression is atomic. In other words, you only have to focus on that one expression. You don't have to worry about the dependencies. You don't have to worry about what the consequences of the speculations are, because that's what the system does for you. Just like in a spreadsheet, when you enter the formula for a cell, you don't think about what are the consequences of that. You just think about that cell. Is this the correct formula for that cell? Yes or no? And if it is, then you're done. Whatever happens, happens. After that, it's up to the spreadsheet to see to it that the proper changes are propagated. You have a question?
So I'm a developer and I want to use this product. I've already got some databases out somewhere that I've got access to. And what's involved in my using this? Like, do I have to go through EspressoLogic.com? Does this generate code that I can put on my own server?
Right. Okay. Let's.
And how much do I have to pay for it?
Yeah. There's no magic. So let me point at this. So this is middleware. So we're not generating code. It's all running in this server here. So if you're making direct JDBC, ODBC calls, it's not going to excite this logic. It's just the same as a J2EE or a .NET server. That if you bought into multi-tiered computing, this is multi-tiered computing kind of in the rest world. All the good parts about that, it's scalable, it's a standard language, and so forth. Plus the bad parts, that if there's the back door, people go through it, the logic doesn't work. So that's as it's always been. Now, this stuff we showed you the JavaScript. It can call your existing stuff if it's well, sort of organized. It can call stored procedures. It can call .NET functions. It can call Java functions. It can call out to that stuff. If it's properly organized, you can leverage your existing logic. But I would want to say that all systems are set up to make that easy. Sometimes it's. If the logic isn't the buttons, you got a big problem.
So essentially, I would set this up. This would run on your server. It would then access whatever data I pointed it to.
Yeah.
And my application on my client would be actually making calls to Espresso Logic to get the data.
Exactly. Well, exactly right. Let me expand on a little bit. Physically, these servers, because they're basically Tomcats underneath. That bank of servers, that cluster of servers, can run on the cloud. So on Azure, for example, or Amazon, if you're that way. Or if you're a bank or a medical, agency that says nobody's accessing my data through the internet, forget about it. Then you can get this as a VMware appliance or a Docker appliance and run it inside your car. Okay. But in any of those cases, it winds up being a service. Okay. Did that answer your question? Thank you. Good question. How much it costs? It's virtual for you, it's free. It's free to try. Developer, you're going to jump me out. Developer versions cost $50 a month.
Yep.
And a typical deployment, running application costs more like $1,000 a month. It goes up to there as the scale gets bigger. And it's charged as a service. It's not basic, it's not per developer or something like that.
So regardless of the data size?
Say it again?
Sorry. Regardless of the data size?
Yeah.
$1,000 a month.
Yeah.
It depends on
And
the
that's
size
how
of the
many-
machine.
And how many servers you want. Right. See, this scales naturally, right? One of the things I did not mention about REST is one of the definitions of REST is it's stateless. That's a wonderful, stake to put in the ground, because that means that you can set up as many of these things that you don't have to have a user tied to a given node, and that node goes down, blah, 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 blah. Okay. So you get this kind of horizontal scalability, but we charge for it.
So this tool is useful only when I wanted to use multiple databases. Let's say I only have SQL Server. I only have how to deal with SQL Server.
Yeah.
So
No, I think think, single database is the simple case, right? The multiple database is the hard case. So if you got the simple case, life is good. Most of our customers have a main database and something else they're trying to integrate. Not always, but that's often the case. And I think that's one of the big beauties of REST is it can hide how many databases are there, and you get a nice simple API that you just call. So I would like you to think of REST as the next level up from JDBC or DBC. It's basically your data access layer. Right? So whenever you're in your controller and it's time to read data, write data, use REST, whoever's. And that REST service ought to be doing what application servers do. Behind the API ought to be enforcing the logic and security to make that data safe and secure. Okay? The big difference between REST is it's networked and it's SOA. Those are gigantic differences, right? Okay.
So can you talk about a little bit about
I have to interrupt. I'm supposed to be giving out t-shirts. So you've asked 3 or 4 questions. You absolutely get to have a t-shirt. And if I see anybody laughing at my jokes, which I haven't seen yet, I don't want to take down this guy's computer. Can you?
Thank you. So the question was, how do you guys handle caching in the case of, let's say, the multi-database or even in any single database, if things are changing in the database. Let's say there are applications today that are interacting to that database through JDBC, right? Or there's some keys coming in.
Yeah.
How do we make sure that those caches coming from the REST server reflects those changes?
Right. So for us, we provide caching for a transaction. So the number of IOs or SQLs that you do is like down a couple orders of magnitude because of that. But our cache, we call it a transaction cache because it only lasts for the duration of that particular transaction. So when we need to get data, we get it back from the server. And we're expecting the server to have a good cache, and we're expecting, in most cases, the REST server to be right next to, like an application server, right next to the database, so it's going to be a quick call, as opposed to the mobile phone, which may be a long way away.
I don't know if that answered my question, but I think I was talking about in terms of, let's say you're building like a mobile app, and you're calling the REST server. You're calling this REST service, you get new customers, right?
Right.
Now, does that always go to the backend?
Yes.
Oh,
yes.
Regardless. Cache. So there is no caching.
There's no caching in here because we want to keep it stateless, and all those bubbles become pretty nasty because we very much believe in kind of the SQL notion that there may be base tables, but that's not the way you want to access them. You want to access these views, these resources. So that all of these different sort of cuts of the data, and trying to reconcile a cache for all that stuff is a very tough job.
But in case of so that's where I see a little bit like a disadvantage, right? Because when you're building a custom REST service for your application, you can also expose write operations and business logic to ensure that you do get some caching.
Yeah, and that's a very good point. So, for example, the list of state codes, for example, you wouldn't want to keep reading that, for example. So, even though we're talking about a high-level automation, it would, if you're looking at us as a vendor, we would have to prove to you, and we would, that we also enable you to provide your own, endpoints with using whatever caching you want to use to provide certain high-performance services. So, the ideal system is highly automated, but has all the hooks you need to do the last 5% stuff. That's at least the design objective.
So you using the JDBC to access the data?
Yeah, at one point we used Hibernate, but it was not fast enough. So we're using JDBC. Okay? So, that's logic. There's a similar story for security. I guess we could just push forward on the slides and have a little bit of that. Also on the right?
No.
So this is a pretty major statement. I mean, to have a handful of rules, literally a handful of rules, automate like a dozen transactions and replace hundreds of lines of code. This is an industry where we all walk over hot coals to get a 25% advantage. And I'm standing up here with a straight face saying, there's a 40x opportunity here by using this reactive logic. So that's a pretty interesting technology. Let's go to the next slide. Oh, wait, I'm not nice. There's a similar story for security. It's getting a little late, so I'm happy to show you that the idea is it's great to modify. It's great to make sure that all the updates are happening the right way, but we don't want people reading their boss's salary and stuff like that. So there's kind of a two-part dance going on. One is people are granted access to the system. They get a series of roles or not. And based on those roles, we'd like to take the security down to not just you can access this resource, kind of like you do in a database, but you want to go lower that says your roles tell you what rows and columns you have access to. So when you make a query, we sort of inject your security profile into that query per your roles, and you get back less data, for your roles because that's what the server is doing. Does that make sense? So row and column level security, that's a lot of what applications do, right? They sort of fabricate these SQL streams based on who you are. That's now logic you can take out on your applications because it's something that should be enforced in the server anyway. It always should have been a server function. Okay. This is the secret root. We all are probably aware that there's this NoSQL thing floating around. We should say a few words about that. So, what are some good reasons and some not so good reasons on when I should use NoSQL versus SQL? Well, good reasons for using NoSQL is good for archiving data. Just write this bunch of stuff in. It's simple. Good for logs. Good for unstructured data. It used to be a reasonable reason to use NoSQL because NoSQL, most of them, natively produce a RESTful API. And that's what your mobile web developers want. They want the RESTful API. And back in the day, building a RESTful API to a SQL database was like months of work, right? So NoSQL looked like kind of a way to get there fast. I hope we've convinced you that you can now have a RESTful API just by basically clicking a button. So there's reasons to use NoSQL, but one of them is not to get a good RESTful API. RESTful API today is as simple as click on it. So that's my comment about NoSQL. Now, most of the customers we have are very interested in NoSQL for the same reason they're interested in multiple databases. You want an API that combines SQL data and NoSQL data into one API. We actually can we show an example? I think we have that. Right? So you're logic now.
I think we do. Keep talking, I'll go first.
I'll always keep talking.
You want a teacher? No, I don't want a teacher.
No, he left. I'm going to visit he left. And you smiled, so no. Anybody want a t-shirt? Okay. You just send the rush back. Did you found your screen? I got plenty. Much rather hand it out than carry it back home. The main thing to do is not knock anybody's computer over. That's not in our budget. Everyone's treating you well?
Yeah, well, I don't have thing acting right. But the general notion is basically, as you define resources, here we have a resource that is mixed. In other words, the top resource comes from SQL, and the Mongo orders comes from a Mongo database. This is the join between the two. As you can see, we're using a Mongo syntax here. If you use Mongo, they don't use SQL. They use their own syntax, which is kind of a pain in the neck. In the neck, that's it. So you define it this way, and then on the server, basically the data is fetched from both data sources, joined together, and then what you get back is one JSON result containing data from both sources. So that's pretty straightforward.
Slide time. We're almost done.
You?
One of them, how many programmers here like to do maintenance? We hate it, right? And my joke about maintenance is more like archaeology, right? Because you spend 90% of your time reading somebody else's crappy code to figure out where to put your stuff. You're not spending any time doing your stuff, right? Why is that? Another programmer joke is, well, let's take the last program you wrote, and let's just change the order of the lines and see if it works. Probably not going to work. That's because you own ordering. That simple statement is why you have to spend most of your time reading somebody else's code to know where to put the 5 new lines in that'll make it work for some maintenance change, right? What if the system owned the ordering, not you? That's what reactive programming means, right? When we build a dependency graph, whether it's in a spreadsheet or this kind of database stuff, that dependency graph dictates the order of execution. And in maintenance, if you change the rules, you ipso facto change the dependency graph, and the system will adapt the order of execution for your new rules. So instead of you spending most of your time figuring out where to add the rules, you just roll them onto the pile, and the system sorts it out.
And once again, I think that the spreadsheet analogy holds perfectly here. When you define a spreadsheet and you create a formula for a cell, you don't think about when is this formula going to get executed. You just define it, and it's up to the system to execute it whenever it's required. So by divorcing this definition of what to do versus when to do it, that just changes the equation completely. I look at this as basically a spreadsheet is kind of like a bucket of definitions. You define individual formulas and sums and whatnot. You throw them in the bucket, and the system will sort of sort it out and organize it in a coherent whole. And it's very much the same notion here. You define each expression individually, and it's up to the system to reorder it. And as Val said, it's not at all unusual to add or modify an expression, and to have, in fact, the system change the order of execution completely. You don't even have to know about that. You don't care. That is up to the system to figure out and to manage.
And the other piece is, if I go to change your code and I put code in there, can you be sure the system will work right? Even if it's in the right spot. No, because you don't know that all the places that ought to call it, in fact, call it. To really know that you've got it nailed down, you've got to basically understand every single path of logic through your system. That's a ridiculously hard problem. Whereas in a spreadsheet or reactive, it's not your job to call the rules. It's a very profound statement. You drop the rules into the bucket, Nexus bucket, and it's the system's job to say, here comes some updates. Do we have any rules in the bucket that apply? If so, apply them. That's not your job. So if you drop the rule in there, you can be sure it's running. So there's a level of quality here kind of built in that you really can't do by hand. It's a very hard thing to do. Which is what I just said. Okay, so I hope I've convinced you that REST is worth looking at. It's a networked way of getting at your data to support mobile apps and integration across different architectures. So I think, I believe the REST is, I think it's a much bigger impact, I think, potentially than J2EE or .NET, because it's multi-architecture. That's a very, very big deal. So I hope you'll take a look at REST if you haven't already. But I'd also like, just almost for fun, kind of just whimsy, I'd like to show you something I think you could use tomorrow. So what on earth am I looking at here? Let's see, it's a list of customers. Click a customer, I assume that would show me the customer on the right. Orders for that customer. I look at kind of a database app, right? Kind of a very generic sort of database app. You've probably built billions of these in your life, right? And so what's special about this one? Nothing in terms of its functionality. It does just what all your other apps probably do. The difference is you didn't program this. This got created by the system from the schema. That's a huge statement because it's actually a very functional app. If we look at the line item, don't go too far next. If we look at this, so here we're seeing the customer has a purchase order and has this list of line items. The actual schema, if you looked at it, would show, item ID and part ID. And the system looked at it and said, who wants to see part ID? It went to the part table, which it saw the foreign key, and said, what are the other fields that make work? Oh, here's name. That's probably something that somebody would much rather see. So it did an automatic join for me, and in fact put a lookup on it, because this is a fully updatable application. Because guess what? It's sitting on top of the REST API with the logic and security under it, so updates are safe. And we do a good job of updates. For example, this little triangle means this is a lookup. So I can get a list of part numbers here and pick one that way. So this kind of app comes for free. So tomorrow, when you're messing with your databases and trying to make test cases or see if your test cases work, rather than sitting in your SQL tool and issuing low-level SQL command after low-level SQL command after low-level SQL command, you could be doing this, because you don't have to program it. This will be up in like 20 seconds. You'll still use your SQL tools, of course, but you don't have to for this kind of like walk around the database, see if the data is okay, maybe fix it. This is now something that's kind of free.
I'd like to add a little bit to this because
you wrote it.
Well, me and some of my best friends, yes. So when Val says this is for free, it doesn't mean talk about money, of course. This basically falls out of the box. As soon as you have your connection to your database, your application, this application will be up for your particular database or database. Now, this is kind of cool and interesting, but not earth-shattering until you start realizing that if you have the logic and the security defined as part of your system, there's not the possibility, though certainly not the obligation, of passing this around. So, since we have a lot of database people here, I'm assuming that we've all done data maintenance. The favorite activity of everyone, I'm sure. Something's broken, we don't really know why. There's some stuff that needs to be corrected in the database. And in my experience, at least, that role very often falls to DBAs or data owners. Not necessarily because they particularly want to do this, but simply because there's access and privileges and expertise issues. In other words, you can't just let business users roam free in the database. They're going to break things. Well, they're not going to break things if you have the logic and the security defined properly. And therefore, this opens up the possibility of, in fact, offloading a significant portion of this work to the people who really should own that task. In other words, the business owners who own this data. If the logic is defined properly and the security is defined properly, they should in fact be able to maintain that data on their own without help from the technical side.
Okay. So, thanks for joining us. We're kind of done here. What we've seen tonight is what is REST and why. I think it's a big deal. I mean, obviously you'll reach your own conclusion, but basically I look at it as the next generation beyond JDBC, ODBC, network, SOA-based database access technique that can now be made in front of any SQL database very easily. can be extended with literally point and click to deal with these nested documents over multiple databases. That's a big deal. With enterprise class logic and security inside that API, these are pretty big deals. So I'd like to encourage you to think about them. And thank you for your time.
Okay, thank you, Val and Max. Very interesting presentation. Thanks to everyone for coming tonight. And watch for our emails for upcoming meetings. I promised I was going to send you around a piece of paper during the presentation about if you wanted to volunteer for a SQL Saturday. I'll just get that out right now, and if you want, just come by and see me before you leave. Thank you.
Thank you.